Excellent. Yeah, so thank you very much for inviting me to speak at this conference. I got the invitation, and a few days ago, for some reasons, I had issues with my machine. And then I learned the hard way some of the logistic challenges you can have when you're working from home due to the pandemic. These challenges can unfortunately be more important, more damaging for certain, if you live in certain regions of the globe rather than in others, because I had a new laptop to be shipped to me and it takes much longer to get here. Unfortunately, we found a way to have access to the system and to my document, and I'm happy to be able to do this presentation today. So what I would like to talk about is...
You're not sharing your screen anymore.
Do you have it? Oops. Yeah, you should see it now.
Yeah, better.
Excellent. So what I would like to talk about is how machine learning or artificial intelligence, if you prefer, as it is called today, is used to solve various challenges across the globe. And in particular, how where you are in your background can contribute to the set of challenges that you decide to solve. And ultimately, obviously, this has an impact on economic equality. So I hope in that regard it is related to the main topic of this conference. So the challenges and the applications of machine learning I'm going to talk about have chiefly been tackled at Google, some of them by my colleagues in the Accra office, but others by other researchers and engineers sitting at other offices, whether it's at it's in Tel Aviv or oops. Seems we are having challenges with the shared screen.
You're back.
Okay.
It seems like whenever you have your camera on, it disappears. So perhaps just sticking to the slides.
So I should just remove the camera. Is that
perhaps
right?
Looks like
okay.
That.
Okay. Or I think I would just try to keep this tab active. Probably that's the reason. So as you know, now as other presenters have certainly mentioned, there has been tremendous progress in machine learning in the past years. I like to give this example where if you consider one of the most widely known application of machine learning, which is image recognition, and one of the most significant benchmarks for image recognition, which is ImageNet. In 2011, the best systems were achieving 26% error. And that accuracy went down to 3% error in 2016. Meanwhile, there has been some evaluations saying that humans on average make 5% error. So this is quite significant in a matter of 5 years. And these developments have sparked, and obviously they came initially because of the strong interest in the field, but they have also motivated a large number of researchers and engineers to enter the field and contribute. And as a result, for example, if you consider a platform like Archive, where we post most of machine learning papers today, in 2019, you had about 90 new machine learning papers every day, which is significant considering the numbers you could see around 2011 or 2013. In fact, this goes so fast that it even surpassed in terms of speed the Moore's law. So machine learning is being used today to solve all sorts of problems. And in 2008, the National Academy of Engineering published the grand challenges of the 21st century. And you can see all these challenges in red. All those that are in red are actually being tackled with heavy use of machine learning, especially at Google, obviously in other organizations as well. The experts working on these challenges live in a very reduced set of locations in the globe. So this map is extracted from a study by a company called Element AI. They surveyed a few years ago where the machine learning experts are active. And by machine learning experts, they used LinkedIn profiles and stuff like that, and compiled those who were listed themselves as actively working in the field, publishing papers, working as engineers, etc. And as you can see, the bulk of researchers and engineers in this field are located in North America, in Europe, and in Asia, chiefly in China and Japan. The rest of the world is barely represented, and especially you can see this whole gray area in Africa, where you barely see some of these purple dots. A few years ago, we started a new research center in Accra, where I'm based normally. So this center is part of Google AI, which is a distributed AI organization with offices in North America, obviously in Europe, but also in Asia. So this one was the first in this region of the globe. So we are a team of engineers and scientists working to tackle some of the challenges that are interesting from a scientific perspective as far as machine learning is concerned, but also relevant to local populations. And I will be talking about some of these challenges next. So I live on a continent where all projections say that we'll be about 2.4 billion by 2050. Keeping in mind that we are about 1 billion people right now, and by far the youngest population on this planet, this doesn't come without challenges. Of course, it comes with many opportunities as well. But as researchers and engineers working in this field, where you are based, to a large extent, determines the kind of challenges that you decide to tackle, because research and development itself, I strongly believe, cannot be detached from the environment in which it is performed. So some of the researchers in our team, and more particularly a gentleman by the name of Ernest Muebaze, who used to be with us recently and who is now faculty at Makerere University, with others, worked on using machine learning in agriculture. In particular, asked the question of how can we use modern techniques in AI in order to improve plants' health by using automated diagnosis. So if you look at this plant, for example, which is a cassava one, how can we just with a mobile phone diagnose this plant and take action before it is too late? It turns out that the same techniques used for doing semantic segmentations for various applications on the internet, deployed on the internet, can be used to solve this problem as well. And with modern techniques such as quantization and compression, these models can even be deployed on smartphones, in fact, on even low-end mobile devices, which farmers can use when they are in their fields. So basically take a picture, and what the application brings is a segmentation like this where it precisely indicates which parts of the plants are not healthy. And these can be used as an early warning system or as an initial diagnosis, so the farmers can take action while it is still time. So another important application that has received attention here is how do we use machine learning and modern techniques in computer vision as well in order to improve our understanding of populations. So this is important because many of the decisions in terms of policy making are based on measurements, on statistics that take time to compile, that sometimes are obsolete, but nevertheless, the decisions that are taken based on those numbers can have huge consequences on how various things are allocated, like capital, or where do we build, where do we increase water supply, where do we build new schools, etc. So as the world have more, the world's population increases, it becomes more and more important to have accurate statistics in order to guide decision making in terms of policy. So, for example, if you look at the buildings of the world, these buildings they look very different in different places of the planet, but nevertheless, they are captured differently by satellite imagery, which is the main source of for building maps, for example. So if you look at this this picture, you have buildings from various parts of Africa. If you look at the top left picture, it's this is a slum in Nigeria, which is actually built underwater. So if you look at these roofs, they have very different structures from the ones that you see on the right bottom of this image, which was taken in Kampala, for example. So how do we build models that are accurate enough to capture all of these variations, and then to allow us to understand where people live and how many people live in certain areas, how the cities grow, where refugee settlements are appearing, and things like that. So this is a very challenging task, which until very recently, most machine learning models could not solve. So if you look at the Google Maps, for example, in many areas, you may see something like this. And this is a direct consequence of the inaccuracies of our models. So in this map, you see very few buildings that are represented. So it's these squares and rectangles. It doesn't mean that in reality, there are no buildings here. It just means that the algorithm that takes the satellite image and then extracts the building from the satellite image in order to create these maps is not accurate enough. Now, if you have a service, let's say a ride-hailing service or another service that is based on information like this, you may end up having a different quality of service for people living here in Togo if you compare it to maps which are more accurate for people living in New York, for example. So for example, if you look at the same satellite image corresponding to this area, you can clearly see that there are many buildings here. They're just not captured by the algorithm. So what was done by a group of people in Accra and in collaboration with others in Zurich, and the whole team was led by John Quinn, who is a researcher in Google AI in Accra, was to design new algorithms, new models, and train those new machine learning models in order to improve their detection capabilities of these footprints, especially for when these buildings have shapes that are very different from most buildings that are in other parts of the world, right? Like in Europe or in North America, where these things are considered to be more regular and the streets are very very regular. This is, by the way, also true for the roads. And this whole thing resulted in a significant improvement of Google Maps. So as you can see, the same map now with this new algorithm results in substantially larger number of detected buildings, and hopefully this will result in better services. So as you can see, if you don't experience the problem and the challenges, sometimes it's very difficult to understand to what extent these things can be the service, the quality of the service is different when you live in different locations. And we experience all of these things just because we live here, so we know how different the quality of maps is. So another project I wanted to talk about is about how machine learning is being used to advance health informatics. So this project is from researchers at Google with collaborators at other institutions in North America. And it's about diabetic retinopathy. So diabetic retinopathy is the fastest growing cause of blindness on the planet. And it's estimated that 415 million people are suffering from diabetes, and they are all at risk of diabetic retinopathy. And if you look at the projections, these numbers by 2040 will grow significantly in regions like Southeast Asia, Middle East and North Africa, and also Africa, doubling in certain cases. So this is quite concerning. But it's even more concerning is that even though this can be cured, it requires people to be diagnosed early. And there is a huge shortage of ophthalmologists. So how is diabetic retinopathy diagnosed? It's diagnosed by just looking at images like this, like these ones, where the ophthalmologists look at the retina and detect certain kinds of hemorrhages, right? To discriminate between healthy and diseased eyes. Now, you need ophthalmologists. You need trained ophthalmologists to do this. And in certain parts of the world, this is a very scarce resource. So what the researchers and engineers in this project did was to collect data, significant amount of data, and train deep learning algorithms in order to automate this diagnosis. And they eventually managed to get high accuracy models that can allow accurate early diagnosis of diabetic retinopathy. And hopefully this can help people to be treated before it is too late, because half of people who get diabetic retinopathy, actually, they become blind before they can even see an ophthalmologist. And these numbers were from a study in India. So another last application I wanted to talk about, which is also very relevant to many parts of the world, including Africa and Southeast Asia, is disaster prediction. So how can we use machine learning today if you live in areas that are prone to floods, for example, in order to very early on predict the disasters and have people take the right measures before it is too late? So in the particular case of flood forecasting, so the team of AI researchers at Google sitting in Tel Aviv built an app that is actually now deployed at Google for people living in India, where they can get very early warning signals of floods. So this used machine learning with meteorological models and stuff like that. And this potentially can have a significant impact in terms of saving lives and similar things. So I think the main similarity between all of these applications is that it is developed and built by people who were aware of the problems. And they were aware of the problems because it is a relevant challenge and a pressing challenge in the areas where they are. And that's, in my opinion, a critical feature of transformative research in terms of making machine learning and artificial intelligence at the service of economic development, and in terms of and also to reduce inequalities and improve people's life. So this obviously doesn't happen without the expertise. So expertise, as we know it in this field, is not well distributed. So on our side here, we're trying to contribute to that area as well. So we created a few years ago the African Masters of Machine Intelligence. This year is our third cohort, where at the end of this year, we'll be graduating about 150 students in total who are now working in various companies, in the public sector, in NGOs, and helping organizations, chiefly in Africa, use data science and machine learning techniques to solve their challenges. And those challenges include some of the ones that I mentioned in this talk, like the satellite imagery analysis project. So I'm just going to wrap up by saying that machine learning, I believe, can be a force for good. And I'm as a researcher in the field, I spend some of my time working on so-called fairness problems. So these are interesting problems because when these algorithms are deployed, they can be deployed in critical applications with potentially huge impact. But that's, I think, just one part of the problem. Another part of the problem, which we should also keep in mind, is what are the challenges and applications that we decide to solve with machine learning? Because deciding to solve certain kind of challenges only is also one way of discriminating and deciding what is important and what is not, and therefore serving certain populations and not others. So that's part of what we're trying to do here, and I'm glad to see that this is of interest to many people in this conference as well. Yeah, so obviously none of these things is easy, but seeing the enthusiasm and all the interest around the talks and the conference and in the community at large, I'm hopeful that that the future is exciting, at least in this area. So thank you very much, and I'm happy to take questions and discuss remarks.
Thank you very much for your talk. So I think we have already one question from the audience by Diego.
Yeah, can you guys hear me?
Yes.
Oh, perfect. Moustapha, thank you very much for that awesome talk. It's very nice to see the actual applications of all this stuff in real world issues. I work in agriculture, and agriculture is one of those areas that's generating a lot of data. But the issue is becoming of actually sharing that data and power relations, right, within the food sector and the food production systems. And I'm just curious, what is your guys' experience in Ghana with the sharing and generation of data, and like what model are you guys following? And what I mean by that is, like, do you guys generate the data and then everybody shares in the benefits of aggregated data, or like the aggregators buy that data, or what's going on there?
So this is an excellent question. So obviously there's data is part of the challenge here. So I can speak about our own experience, at least from about the project, the crop disease diagnosis project, which was called CropNet. So the data coming from that project was actually collected by farmers themselves who were part. So I think for this to work, for this type of applications to work, it has to be built in a collaborative manner. I mean, obviously, this is true for any application. If you're going to solve something for people, you should involve them from the beginning. But this is especially true for these applications. So, so we worked with the Makerere, the AI lab at Makerere University, where actually the lead engineer in this project came from, and they had a set of people, group of people who worked with farmers to collect this data. I think, in general, for this type of application to flourish, we need better policies and quote unquote playbooks to collect massive data sets with all the safeguards in place, like the consent of those who provide the data, but also make sure that those who provide that data have the right infrastructure, because one of the challenges here is obviously the internet, right? So for people to collect the data and share it with us, they need airtime, they need internet connection, which is not always obvious, especially in rural areas. So you have to contribute into paying their the airtime or the internet connection. So you have all of these challenges, and it is clearly not a solved problem for us or for anybody working in this space. And I think a lot of reflection is needed, a lot of discussions and thinking is needed in order to come up with the correct protocols that can be replicated to collect this kind of data.
Thank you.
Yes. I guess I also have like a more high-level question again. So if I understand your talk, I guess you were talking a lot about how your background or your situation can affect what kind of problems you decide to solve, right? And that rings very true to me. And I think it can be true for various reasons. It could be true because of the kind of knowledge you have, or because of your material interests, I guess, or it could be because of the degree of empathy you have to different people in different situations. But I guess what I'm wondering is like how you think about to what extent that's also affected by the institutional constraints you face. And for instance, I mean, in some ways, no matter what kind of knowledge or empathy you have, if you're say in a certain profit maximizing company, then that's going to constrain what you can do and cannot do. And I was wondering if you have thoughts on that.
Yeah, absolutely. I think all of these things are, are ingredients that contribute to what you decide to solve, right? So the background you have in terms of knowledge, technical knowledge, contributes to how you will be solving the problem. Where you are and the rules that govern what you can do are constraints that dictate to a large extent the kind of problem that you can solve, and by the way, how you can solve them as well. Your immediate environment plays a critical role in the problems that you will select, that you will decide to solve, right? So if you're in North America, for example, where like the most widely used way for transportation is cars, then self-driving cars become important, and then you may elect to work on self-driving cars and using machine learning to build better self-driving cars which are safer, etc. And it becomes really, potentially an important challenge to solve, because it's important locally, I guess. I'm not from North America, so I don't know how important it is, but it apparently is. But if you are from this region, as I am, other things become suddenly more important. I mean, we have here pressing issues in health and in agriculture. We want to understand better their populations as well, to make better policy decisions, because the statistics agencies are not, census is extremely expensive, as we all know. So it consumes resources. So, you elect to solve different problems as well. So there are various layers. I think that's the answer to the question, probably, at least my answer. And one layer is where you are. And that's why one of the things I spend most of my time on is to contribute to education, because to make sure that in the area where we are, the talents are there as well, people who are trained to solve these challenges. Now, if they have the technical knowledge and they see these immediate challenges, obviously they may be constraints in what they can solve, depending on the working environment in which they are, right? So if you work in an organization that says you should open your eyes on this and close your eyes on that, then obviously there are certain problems that you will not be able to solve. It depends on what you do, but that becomes very personal decisions, right? So if you're in a place where you cannot solve the kind of challenges that you want to solve, and that is actually very important to you, you should just go to a place where you can solve them, if that is possible. I mean, those decisions are complex. They are taken at a personal level, but that's my opinion about this. As far as I'm concerned, I'm happy to be able to work on some of the challenges I mentioned in the talk. Yeah.
Thank you. Who's next? Everybody's tired after 10 talks. Right. I'll find in a minute. But for now, let me say this was the last talk for our conference. I found it extremely interesting and instructive, and a lot to think about and to be confused about. We are also going to post the recordings of all the talks on the YouTube channel for all of you who agreed. And I've already uploaded for most of you the papers and slides where you sent them to me. And yeah, I hope we stay in touch and continue these conversations. And thanks to all the panelists for participating.
I think a big thank you in return from all of us to both Binte and you, Max, for bringing us together and curating such an amazing 2 afternoons of discussion.
Plus one. Thank you very much on that. Yeah, for inviting us.
Yeah, absolutely. Thank you to Binte. Everything went extremely smoothly, which is not usual.
Thank you for having us. Yeah.
Yes, thanks so much.
All right. Have a good afternoon, evening, depending on where you are, and see you all around. Bye.